and our next panelists. So we're now going to chat through a case study which will explore and examine the benefits of open networking to boost performance. And I'd therefore like to introduce Barry McGinley, who's a technical sales engineer for EPS Global, covering the EMEA region, and Robin Taylor, who's the founder of Zetta Connect. And these two guys are going to have an open debate and an open discussion in front of the whole world to explain to us exactly what the benefits of open networking are. Over to you guys.
Cheers, Steve. Thanks very much. So yeah, the benefits of open networking or disaggregation, as some of the kind of big carriers or telcos are calling it, to boost performance, looking at delivering Gigabit Britain. So I'm Barry, pre-sales engineer, network engineer with EPS. So what I want to do is first have a look at the open networking ecosystem. So this kind of all started around 2009, and Facebook decided they wanted to redesign their entire infrastructure. So they got a team together and they redesigned their switches, their software, their racks, the cooling, everything. And that data center is still going in Primeville, Oregon. But the big thing to come out of it was that they open sourced all of the devices, and then created the OCP. So that's the bottom icon there, the Open Compute Project, along with Intel, Rackspace, and a few other guys. So OCP look after kind of the bare metal hardware and the software, so open source software like Sonic. And the way it works is, say we'll take Facebook for example again. They'll say, right, we want a 10 gig switch with 48 10 gig ports and say 600 gig uplinks. So they'll give that design specification into the OCP, and then hardware vendors like UFI-Space or EdgeCore will go off and build the specific switch to that design specification. And when it's accepted by the OCP, they actually then give all the information back to the OCP so anybody can build it themselves. The next organization is the ONF. That's the Open Networking Foundation. And they started in 2011 as well. So it was primarily to look after OpenFlow, which was the first protocol to separate the control and data plane, and to kind of push the benefits of SDN in general. But then 2016, they kind of changed tack a little bit, and they started a project called CORD, which is Central Office Re-architected as a data center, and started working with some of the big telcos and carriers. The final organization, I suppose, in the ecosystem is TIP, or the Telecom Infra Project, and they started in around the same time as the ONF started CORD. So they have projects in access, transport, and core and services, and then there's more projects inside of that again. So they're kind of the community and where all the collaboration happens between all the big tier ones. So the benefits and attributes of open networking, or disaggregation as it's called. So we've open hardware and we've open software goes on top of it. And this is disaggregation, separating the hardware from the software. On the attribute side, we have open hardware, white box, bare metal, and bright box. So bare metal is a switch or a router with nothing on it bar a bootloader called ONI, and that now allows us to install a NOS on top of it. A white box is a bare metal switch which already has the NOS on top of it. So Cumulus did Cumulus Express, IP Infusion are doing IPI Pro. And then finally we have Brightbox. So just a little bit, so that'd be HP and Dell, but a little background that Acton Group, who own EdgeCore, make the majority of the switches for these guys. So a 10 gig switch that EdgeCore sell, a bare metal switch, is the exact same as what Dell and HP sell, just with a different badge on it. And the same process happens. ONI is the bootloader. They have to install their operating system on top of it. We've open software, so we've open source and commercial software and software controlled infrastructure. So the benefits. So disaggregation provides freedom, so it removes vendor lock-in. And this is one of the most important parts. Greater control over the network, rapid innovation, which is really important as well, because now the hardware guys can go off and build the hardware, do what they do well, and the software guys can go and do what they do well. And obviously software can be provisioned far quicker than the hardware. So we get rapid innovation. Again, reduce CapEx and OpEx. So there's a bit of a yin and yang to the CapEx and OpEx, but if you're going bare metal with an operating system sitting on top of it, and you're going to manage that individually, there's obviously huge CapEx savings to be had. So disaggregated applications helping Gigabit Britain. There's too many here to go through in any sort of detail. It just gives you an idea of how many devices there actually are now, bare metal devices. So we have, on the access side, we've OLTs, so XGS-PON and GPON, or any PON. Aggregation switches and routers, virtual BNGs. Tibit is an interesting one. It looks like a transceiver. You stick that in a 10 gig port and you can create your own XGS-PON network. So really good for enterprises. You can split that 164 or 128 ways then. We have white box transponders with coherent optics, open road M's, nice little product here, 400 gig switch, can go 120 kilometers using 400 gig ZR optics. Per port, it's about as cheap as you're going to get. On the routing side, cell site routers, which have been really, really successful. I think AT&T are installing 80,000 of them into their network. Standalone routers, aggregation routers, and then distributed chassis routing. I'd love to get into that a little more. It's like, so now we can have thousands of ports basically. So if you take a spine and leaf within a data center, so we use a Qumran 2C or Jericho 2 as the leaf. That's up there, Broadcom switching ASICs. And then above that, we use the Ramon ASIC, which allows us to create the fabric. So now we can scale to thousands of ports basically. And on the data center side, we have the data center side's been going for 10 years, so it's very mature at this stage. We can create fabrics over multiple data centers, huge variety of NOSes now, 400 gig moving to 800 gig, and lots of different products at data center interconnect as well. As I said, I could probably do an hour on each of these individually, so I'm not really doing them any justice. So EPS, I suppose, our role in open networking. So looking in, there's a lot of products, there's a lot of vendors, a lot of software vendors, a lot of hardware vendors. So we kind of sit in the middle of that. We work with all the software vendors and the majority of the hardware vendors. And what we can do is just take some of the hassle out of it. So instead of wondering which NOS to put on or which to trial, we can help you with that. And then when it does come to deployment, we will install the NOS and the licensing onto the box and bundle in interoperable transceivers. So basically the boxes are ready to slide into a cabinet. So you get all the benefits of open networking without the little hassle parts in the middle, I suppose. Okay, so now I'm going to introduce Robin Taylor. So he's the CEO of Zetta Connect. Hey, Robin.
Hi, Barry. Thank you very much for inviting me on today, and thank you for the ISPA members for having me today, and thank you, Steve, for the introduction. I'll kick off by telling you a bit about Zetta. So I founded Zetta back in 2017 to assist tenants of commercial office space with the seemingly simple task of getting connected, which, with the minefield of way leaves, access issues, all of which have been mentioned by some of the earlier sessions, as well as potential civil delays if your chosen carrier is not in the building, we came up with a solution of a fiber backbone to help landlords and developers make it easier for occupiers to consume that connectivity they want. The best way to liken it is you wouldn't let a floor of an office building with no access to electricity. So why should fiber be any different? And this sort of touches on, should fiber be a utility? The fiber backbone model is, in essence, how connectivity is consumed in the data center, with you ordering service from a provider, and that gets delivered to a meet me room, and you order a cross connect. It's exactly the same model we applied to a commercial office building. We build a fiber backbone, and tenant orders that service, and we cross connect it with up to the tenant's floor without need for way leave. We work with everyone who's selling fiber, from the city fibers and community fibers right through to the Virgins and Verizons of this world, to connect the occupiers of these buildings. And everything we do is open access to ensure that any occupiers of these buildings have full choice. And although we're speaking at an ISPA event, we don't actually claim to be an ISP ourselves. Instead, we invite other ISPs to use our infrastructure to deliver their service. And in fact, we have a rule internally that we do not sell or resell directly to tenants of the building. We allow the ISPs to do that, and we just facilitate it. We've got clients up and down the country, so we make it our business to know who's building what and where. A couple of examples. We've got a project in Bath where the landlord is targeting wired school, and we need to bring another provider into the building to facilitate that. And we've engaged with TrueSpeed to assist with this. Further afield, we're working on a few projects in Glasgow with Commonwealth to do that. And I'll just take this opportunity now. I saw there was a question on the last panel session from Jan regarding sharing of infrastructure and MDUs. And this is exactly what we facilitate with our fiber backbone. We can have multiple ISPs coming into the basement, and we provide a shared infrastructure to deliver that service to the tenants within the buildings.
Okay, great. So I don't know you touched on what you do there, but the actual project you brought open networking in to try and help with, can you give us a little more information on that?
Sure. So as a sort of natural extension of the fiber backbones being within the building, connecting a sort of carrier meet me area in the basement of the building to the tenants, and the demand for shorter lead times of services from our landlord clients who are providing pre-fitted out space, who want to have Wi-Fi, and they want to have the furniture in, and they want to be able to move tenants in very quickly with that sort of WeWork level of flexibility. We're sort of taking the fiber backbone model and stretching that. Instead of to the meet me room in the basement, we stretch that back to a data center, and we're using a mixture of wavelength services and managed Ethernet to do that. And we're also deploying it as a campus networks on some of the larger developments to be able to offer very low cost, rapidly provisioned layer 2 service. And that's open to any of the ISPs in the data center who wish to cross connect with us, and they can access those tenants within the buildings. Quick example, we deployed open access blown fiber tubing infrastructure around 100 Liverpool Street, central London. We've provided cross connects to 6 different tenants for 30 different circuits from 7 ISPs within the building, and we have our wavelength bearer coming from Volta data center from our new core that we're building as part of this project to facilitate that connectivity. And going forwards, the intention is to allow our platform to act as an NNI exchange to allow cross-connecting of services between smaller, more specialist niche providers who have customers and don't necessarily want to do their own dedicated cross-connect. So as an example, one of our partners, Luminet, who specialized in London-centric fixed wireless connectivity, have NNIs with us, and that allows other ISPs who have NNI with us to access Luminet services as a wholesale product without having to be in the same data center or having their own dedicated cross-connect or Ethernet service to Luminet's POP within the data centers they're in.
Okay, and so you chose an open networking solution. Why did you choose that over your Cisco or Juniper, and what did you actually choose?
So we looked at the big players within the industry, and for bandwidth and port density that we're looking for, the barrier to entry of the bigger players was just too high for us to effectively be able to deploy the sort of 10 gig services that we were targeting. We're talking 10 gig dedicated Ethernet, and we really liked the fact that we weren't tied to a specific hardware or software vendor. We could chop in and out hardware if there was a particular switch from a vendor that suited our needs. We had a full range of choice. In terms of the solution that we've actually deployed, we've had previous dealings with EdgeCore on their enterprise devices that EPS have been supplying us with, and we're really impressed with the build quality of those switches. And so it was a natural progression for us to look at EdgeCore's white box open networking devices. So in the end, we opted for the AS7712s to provide us with 100 gig ports at the spine level within the data center, and the AS5912s to provide us multiple 10 gig ports. And we were faced with a huge range of choices of operating systems that we could run on those devices, from Pico 8, Open Network, Linux, etc. And with plenty of guidance from Barry and team, we settled on IP and Fusion to run as our NOS of choice. And a big part to play with that was a successful implementation of Linux LUN 2, which is a similar topology, running VX, LAN, eVPNs to our use case.
Yeah, I think they're deploying in Manchester now as well, the same OCNOS as well. So what stage of deployment are you at, or implementation? Or
So we've got some kit heading to the data center, some kit in the lab ready to go. We've been really pleased with the sort of testing we've done so far and the performance of the kit, especially with the support that we've had from yourself, Barry, EPS, and the wider IP and Fusion team in terms of our slightly unique use case for a sort of smaller deployment. Couldn't have been more helpful.
There's a question in the chat for you, Robin, which I'll just read out. It's an interesting approach, at least for commercial property. Presumably, any ISP SLAs run to the comms room. You provide support to the customer for the in-building infrastructure. So who pays for the infrastructure and service? Is it the ISP, the landlord, the occupier, or someone else?
So we try and keep the model as simple as possible. The occupier pays a one-off cross-connect charge for us to go in there, cross-connect their service, test it, and the landlord pays us a recurring annual fee to provide an SLA, and we aim to match the service provider's SLA in terms of a break fix of the infrastructure within the building.
Okay, that's great. So, Robin, Barry's been asking you all the questions. Have you got any for him?
I haven't got any specific there.
good.
I know Barry's got one more for me.
Right. Okay. Fire away.
No, just what does the future hold for Zetta? Just interested to know where you see yourselves in 5-10 years time, kind of thing.
Yeah, so we're welcoming more ISPs to join us, both in the DCs and make use of our open access fiber backbones within the building. And ultimately, as a sort of primarily a consultancy business, we aim to be the UK's leading connectivity consultants, as well as maintaining our open accessibility. As with many others in the industry, we're developing a portal, and this will enable our landlord partners to view all of their properties' connectivity capabilities in one place. And in time, we plan to add on-demand provisioning, so that our customers and service providers can provision their own services once they got an NNI in place, with sort of minimum fuss and the shortest lead time possible.
Great.
Okay, so we're kind of out of time, guys. It was an interesting debate, good discussion. Barry, Robin, thanks very much. I think Audrey's going to get you guys to step away from the stage now.
I know we've got a poll there, so it'd be very interesting to see anyone's feedback on the poll. So thank you very much.
Yeah. Cheers, Steve.
Good stuff. Thanks very much, guys.
Cheers, Robin. Bye.
Cheers.